Alright, now in number 1, A. First, we need to write the capacity of our soda can. I'm using a capacity of 400 milliliter, or could say 400 centimeter cubed. Then, to make it easier for me later on, I would write my radius and height in real life. The radius, I got it out, is 3.17 centimeter, while the height is 15.2 centimeters. Now in number B, in 1B, they say how is it different from a perfect cylinder with a constant thickness, the soda can. Now if a perfect cylinder with a constant thickness has a circle, it's a cylinder, and then a circle. So it's like a geometric shape. We have here like a rectangle or a cylinder, and here we have two circles. But in our soda can, here we have two circles, and in the middle we have an irregular shape, because here you can see it's narrow at the top, then it's constant, then narrow again at the bottom. And it's also curved inside here and inside here. So that's the difference, is that constant thickness is a geometrical shape, while a soda can is an irregular shape. Now in number 2, in A, we need to put h as in terms of r. So we have the equation pi r squared h. We could change this equation to be by r by h, and here we move these. So it's going to be h equal v over pi r squared. And then we change v so it can be only in terms of r. It's going to be 400 over pi r squared. Now, in 2b, they want us to find the area in terms of r now. So the area, what does this consist of? Now we are considering the can as a constant thickness. So we would open it. If you would open it, it would look like this. Alright, so in here we have two circles, and this with the length of the circumference. So it will be area of the body plus area of the circle 1 plus area of circle 2. So S is equal to 2 pi r h plus pi r squared plus pi r squared. So 2 pi r h plus 2 pi r squared. Right? Here for 2b. Now 2c, we want it in terms of r only, but here we have h. So what do we replace h with? What we got here. So it's going to be, s is going to be 2 pi r, place h, plus 2 pi r squared. Then we cancel, and we get this equation. 800 over r plus 2 pi r squared. Now in 3a. In 3a we need to find r. So how do we find r? We find r by taking the derivative of this equation s, and then doing it equal to 0, then solving for r. So the derivative is for s. Now if we solved it, you'll get negative 800 over r squared plus 4 pi r. So we make it equal to 0. And then we solve for r. So negative 4 pi r equal negative 800 r squared times r squared. So remove that. Now r at the end is equal to 3.99 centimeter. Now we need to find h. We got that r is 3.99 centimeter, and then we have the equation of h, which is 400 pi r squared. So we replace r in here, which is 3.99, and we get 7.99 centimeter. And then we need to show that R is the minimum. We need to prove it. So I will use at first the timeline. We have here the positive and negative, and in the middle we have 3.99, which is considered the critical point. Then we take here something less than 3.99, let's say 2, and something more than 3.99, which is, let's say, 5. And then we place 3.99 in the first derivative, and here you will get negative, and here you get positive, meaning this is going down and this is going up, meaning this is a minimum. Now, if you want to graph what do I mean up and down, it will be something like this is going up and then going down and then going up. And here is 3.99. Right? And here. Then in 3b, we need to use another method to prove that R is a minimum. So we take the second derivative of S, which is going to be 1600 over R cubed plus 4 pi right? And then we put R inside here, the critical point inside here, which is 3.99. We will get 37.7, which is greater than 0, meaning this number is a minimum. So now in number 4, we need to compare the real dimensions with the so now let's see the real dimensions. We have R 3.17 centimeter and H 15.2 centimeters. While the calculated dimensions, we have R 3.99 centimeters while H is 7.99 centimeters. And we can see in here a change, and here it's different, it's not accurate. And this may be because we were calculating as if it was a constant, a shape with constant thickness. While our can in real life is not with constant thickness. It has narrow ends and thick body here, so it's different. And then, so this is the reason why these digits are not the same as these. So now in number 5. In number 5 we are considering thickness, which would be, let's say, more accurate for now. Then we will check. So before we used to count it as a 2D shape and as a regular shape, but now we're considering thickness. So the equation is 2 pi RH times t plus 2 pi r squared times 2t, and 2t because we have two circles. Now you would say, like, why, like, is this a rule or equation? You could find this in the rectangular prism equation, the volume of the rectangular prism. We have L times W times H. Now the area of a rectangle alone is L times W. Now when it became a prism, we added H, which is the thickness of the prism. And this is the same as here. We have the area, and then we added the thickness of the can. Then we need to do it in terms of R. So we will replace H again as we did in S, and that's B. So 2 pi r 400 pi r squared plus 2 pi r squared times 2t. Then we cancel as we did before, equal 800 over r plus 4 here t, sorry, times t, plus 4 pi r squared t. So now we need to change t with its value. Its value they given us is 0.001 centimeter. So it will be 0.8 over r plus 0.004 pi r squared. Then to do as same as in number 3, to find r, we need to do the derivative and make it equal to 0. So the derivative of v will be negative 0.8 over r squared plus 0.008 pi r. Now we will make it equal to 0 and solve for r. So it will be negative 0.8 So we'll move this to the other side. It's going to be 0.008 pi r equal to negative 0.8 over r squared. Then we are doing exactly the same as we did before. So 0.008 pi r cubed equal to negative 0.8. Then we remove this and r will be equal to 3.169 centimeter. And then again we find the h in this equation, which is going to be equal to 12.67 centimeters. So now in C, we need also to compare again. So real dimensions, we have here is 3.17 centimeter and height is 15.2 centimeters. Then we have the calculated dimensions. It's 3.169 centimeters, while height is 12.67 centimeters. Now we can see these calculations and dimensions are closer to each other. And this could be the reason because we were based at the beginning in number 2, it was based on a 2D shape, meaning it is not also perfectly accurate. When now we have the thickness, which is closer to the accurate shape of the can.